Leafcutter ants are these fascinating insects found in the neotropics. They harvest leaves from different plants, and they don't actually feed on the leaves, but they actually use the leaves to cultivate a fungus that grows in their nest, and that's what they feed on.
They actually do not eat the leaves at all. They just chew up the leaves and use compounds that are in their saliva in order to promote growth of this fungus that's living opportunistically in the nest.
There are many types of leafcutter ants. The species that we're studying here, Aedocephalotes, is the most prevalent in this rainforest. There are also different ants with different temporal behaviors. Some come out during the night, some are diurnal, come out during the day. That's the kind that we're studying.
Ants can actually lift several times their own body size. It's because of the way their muscles attach to their exoskeleton. They actually have more attachment points than we do. When we use our muscles, we have a skeleton. Ants have an exoskeleton, which gives them more surface area. So literally it's as if our muscles, instead of attaching to our bones and our tendons, we're attached to our outer layer or shell of our body. And so that effectively makes the ants very, very strong.
The ants have a caste system. There are worker ants that do maintenance around the nest, taking out dead bodies, feeding young, building tunnels. And then there are soldier ants with large mandibles, and they attack predators or intruders that come to the nest.
The cool thing about the soldier ants is they often have enlarged heads and really large mandibles, which they use to attack enemies, and they will clamp onto those enemies for dear life. When our crew went out to go and visit our nest where we were doing our research, we found that a millipede had unfortunately wandered into the path, the pheromone trail of the ants where they were foraging, and several soldier ants had attacked this millipede and coated the outside of it and were viciously biting. My students and my crew got to see a little bit of that action and how viciously soldiers can defend any intruders or anything that they perceive to be a threat to the rest of the workers as they're foraging for food.
The purpose of our experiment was to see how leafcutter ants, when transporting their leaves, can adapt to different disturbances.
Leafcutter ants actually use pheromone trails in order to get to and from a food source and the nest. And so what we were looking to see was how the ants would respond if you removed them from that pheromone trail.
Specifically, we wanted to see if, when they were removed from the trail, if they were able to return to their original trail. We found a few interesting things. Leafcutter ants, in most cases, cannot return to their original trail, especially if they're taken far away, because originally we had it where we took them a meter away and none of them found their way back. So we lowered it to about 20 centimeters. They still couldn't find their way back. So at 10 centimeters, they started to find their way back. And then we noticed something strange or something interesting, that the leafcutter ants that made it back, they usually had a smaller ant riding on top of the leaf.
And it turned out that it actually helped out the ants if they had a little assistant riding on the leaf with them, because that enabled them to actually navigate back to that pheromone trail with greater ease than ants that were left to their own devices and were traveling alone.
We think it maybe has to do with something with the small ant sometimes leaves the leaf and scouts for it, and maybe picking up different pheromones in the air. It could also be weight on the leaf. We noticed that sometimes the ant on the leaf would rearrange itself and make the leaf tilt, so that might have something to do with it.